Thanks. I'll probably need them. Well, firstly, I'd like to thank all of you for inviting me here today to tell you a little bit more about what we're doing, and also to Eric and Professor Mu-Young for their great introduction. I think it definitely sets the stage for what we're trying to do here today and what Enerkem's trying to do as a company. So first, to give you an idea of where Enerkem fits in this overall solution for both the utilization of waste and for the reduction of CO2 from fuels. So we're looking to use municipal waste, energy crops, forest residues, and agricultural residues via the Enerkem process to produce various products and biofuels. So to give you an idea of the impact of that, this is there's about 1.3 billion metric tons of MSW produced in the world each year. So once you go through your composting and your recycling and all the different ways of reducing that waste and reusing it back into the market, you still end up with about 407 million metric tons of waste that's currently not economically feasible for recycling and that is non-compostable. So this is really the target material that Enerkem is looking at for feedstock to our process. And the reason why we're looking at waste as opposed to the other energy crops and biomasses that I put up there is mainly because of cost. It's one of the least expensive feedstocks. It's already got an infrastructure in place for its collection and centralization, and that lends itself to utilization by chemical process such as ours. So if we were to utilize this 407 million metric tons of MSW each year, it would produce about 150 billion liters of cellulosic ethanol, which is great. It's about 99% of the global market for ethanol. I don't envision that Enerkem is going to go and capture 99% of the ethanol market globally. And it's one of the reasons why we're looking to diversify to produce not only ethanol and methanol, but these other products as well. Butanol is an example. It's one of the materials that we're looking at producing from waste materials. But also you've got things like acrylates and plastics and things that we use every day. We can produce these things from waste as well, and I think that it's important for companies looking in biotechnology to look not just at biofuels, even despite the need for energy, but also to look at the possibilities of producing chemicals from these materials as well, durable goods. And in fact, the more we can produce durable goods, the more we can capture CO2 in the form of those durable goods and keep it from going into the atmosphere. So it's one way of looking at durable goods as a means of carbon sequestration. So one of the market drivers for using waste as a feedstock, aside from being an inexpensive feedstock, is that landfills are closing in North America. This is the data for the United States, which is a target market for Enerkem. You can see along the top bar graph there that the waste industry in general is moving away from landfilling. They don't want to landfill their material. There's many problems with incineration as well. The environmental effects are very detrimental, both to people and the environment at large. So we're in need of a solution here as well. And the dark blue states that are highlighted there are states that have less than 20 years of landfill life left. So they've either got to implement a new solution for their waste or try and get more landfills. And as you can see up top there, it's not so easy anymore. And people are much more conscious of the impacts of landfilling, and it's also got very significant greenhouse gas effects as well. When material is put into a landfill, it emits not only CO2 but also a lot of methane that's very difficult to control from a landfill. So also the cost of landfilling is increasing. It has continued to increase over the years. So some of the benefits of using a solution such as the one that Enerkem provides, we've got significant environmental social benefits of the solution. We avoid the landfilling and the associated methane emissions. This reduces greenhouse gases. When you're producing fuel from the waste, you're reducing greenhouse gases not only in preventing these materials from going to landfill, but also in displacing the use of gasoline that would otherwise be used for transportation or whatever. There's no land use impact. You don't have to utilize crop. There's no food versus fuel debate here. Basically, as I mentioned, the infrastructure is already there for collecting the waste, so it's a matter of just utilizing the waste at these centralized locations. We complement recycling. It's very important to Enerkem that the reuse and recycle paradigm is kept. So that our target waste is these plastics and materials that are not necessarily recyclable or not easily recyclable. And of course, it has a high social acceptability. So when people can see that you're putting the waste into the Enerkem product process and you have a physical product coming out, people understand much better how that carbon's being utilized in the process. And this is very important from a social acceptability. People can see the product at the end and they know that it meets a certain specification that's normal for environmental and safety impacts. It's got significant economic effects as well. I always like giving the example that in Edmonton, the landfill there, when it was operating, employed about 20 people. And now with the various recycling and the biofuels plant that we have there in Edmonton, and the various other companies and composting and environmental activities that they have there, they're employing about 550 people there. So this is a great economic sustainability story as well. So there's a lot of social impact and good reasons to do this. So quickly about the Enerkem process. What is it? What do we do? Firstly, we take the feedstock, in this case waste, and we gasify it. Well, basically what that means is we homogenize all the various hydrocarbons that are in that waste material, the heterogeneous waste material, into a syngas. Syngas is predominantly being carbon monoxide and hydrogen. And carbon monoxide and hydrogen are building blocks of many of the chemicals that we use every day, including fuels. What we do then is we clean it. This is the third step, and we remove any of the things that we don't want going over catalysts or we don't want in our fuels. This has a major impact in making sure that the process is very clean environmentally. And then what we do is we use our syngas that we've produced from the waste over traditional catalysts to produce the biofuels and products of interest. So we currently have 5 facilities either in place or in development. We started off in Sherbrooke, Quebec. We're a Canadian founded company, spun out from the University of Sherbrooke. We also have our initial pilot plant is located in Sherbrooke. That's where we did much of our process development. We also have a plant in Westbury, Quebec, which is a demonstration scale facility. Processes about 2 tons of waste per hour to produce methanol there. And we also have our full methanol to ethanol pilot facilities there. Our first commercial plant is in Edmonton, Alberta, and there's various reasons for why Edmonton, but this plant is currently built and being commissioned as we speak. And we also have plants in development both in Pontotoc, Mississippi and Varennes, Quebec. So, Professor Mu-Young was saying this isn't yet a reality. This is our plant currently in Edmonton. This is a reality. So we are currently starting our gasification operations there. This is physically on the waste management site, the Edmonton Waste Management site. And this is our feedstock storage building, which is fed by a conveyor coming directly from their waste tipping floors. So this is actually taking waste, municipal residential waste that is picked up at your house every day. They convert that to a material called RDF, which means that they take out the compostable components of it. They take out the metals. They take out what they can and what we don't need in our process. And then they send us the RDF. So this is basically the same process that you saw with the feedstock component, gasification component, gas conditioning, and of course your biofuels conversion. So in this plant here, it takes about 100,000 metric tons of waste each year, and we'll convert it to biofuels, about 38 million liters of ethanol per year. This is the overall waste management site, and this is really a model for waste management in North America and around the world. They have visitors come here to the Edmonton Waste Management site every day from around the world. And then one of the main attractions is it's one of the few places where they have so many different aspects of recycling and reuse in one location that you can visit. So here, Edmonton has two sources of waste pickup. They have black bag waste that's basically your non-recyclable material, and then they have recyclable materials that come here to a material recovery facility. This is a composter, the largest indoor composter in North America. They have on-site electronics recycling. This is the old landfill up on the left-hand side there. It's now currently completely closed. They also have construction demolition debris collection and recycling on site. Those lagoons up top there are where the solids from the sewage sludge comes each day. So they're even addressing that waste stream. And then you've got paper recycling, and of course the Enerkem biofuels facility is right here. You can see here the conveyor coming from the waste building right to our feedstock storage building. So if you have a chance to come to Edmonton and visit the facility, please let me know. I'd be happy to show you around there. So the Edmonton project was really started. They established a goal and a target for themselves to divert 90% of waste from their landfill for various reasons. Basically, their landfill was closing. They couldn't site a new one and didn't really want to site a new one. So they opted to choose a more sustainable path, and so they've implemented recycling and composting and the Enerkem biofuels process to address their waste. And so when we're fully online, the end of 2015, we will be diverting 90% of the waste that was formerly going to the landfill to more sustainable uses. So we had a lot of help getting here, so there was some mention of subsidies, but they're not necessary for the economic model, but we do appreciate them nonetheless. And we've had help from the government of Alberta, City of Edmonton, Alberta Innovates, as well as Natural Resources Canada, SDTC. It's been a long road. We've been in development on this technology since about 1999. So it's taken us 15 years to fully prove this through the pilot scale, through the demonstration scale, and now to go to a full-scale facility. It's not a fast path with these technology developments. It does take time, and I think it's been a great learning for us.